So for inverse cosine here, we can do the same thing. We're going to restrict our domain. So notice this is a cycle of cosine that is not one-to-one. It doesn't pass horizontal line test. So we're going to restrict the domain to be 0 to pi, which is the upper half of the unit circle instead of the right. So that's going to be from here to here. So that's principal cosine from 0 to pi. And it is one-to-one on that restricted domain. So we can reflect that now over the y equal x line. And we can get our inverse cosine. So I'll do this in red. So this point is going to correspond to, let's see, this point's going to correspond to something about right here. And then this one is going to correspond to something out approximately right here. So something like that. So we've got this S curve, but it's vertical instead of horizontal. So doing that, we can define inverse cosine of x, which is saying y is the angle that when you take the cosine of it, you get x. So cosine y equals x. So inverse cosine, y is the angle whose cosine is x. So let's work with this inverse cosine. So whose cosine is x, but it's the angle between 0 and pi. So inverse cosine root 2 over 2. So go to our unit circle. So cosine is the x coordinate. We want x coordinate of root 2 over 2 right here, pi over 4. Or down here, 7 pi over 4. Okay, but we're restricting to angles 0 to pi. So we want pi over 4. So the angle this is the angle whose cosine is root 2 over 2. And that angle is pi over 4. And it's the angle in the range 0 to pi. Okay. Our domain is 0 to pi for the restricted sine function here. So for inverse cosine, the range is going to be 0 to pi. And then your domain is going to be negative 1 to 1, which is the range of the sine function. And then here we've got cosine negative pi over 6, and then inverse cosine of that. So our cancellation laws work with cosine and inverse cosine as long as our angle is between 0 and pi. Okay, but this angle is not between 0 and pi, negative pi over 6. So we have to find the inside and then do inverse cosine of that. So cosine of negative pi over 6. So go to our unit circle. So negative pi over 6 is down here. That's the same as 11 pi over 6. The cosine is the x coordinate, root 3 over 2. So this is saying do inverse cosine of root 3 over 2. So that's the angle between 0 and pi whose cosine is root 3 over 2. So let's go back to our unit circle. Cosine is the x coordinate. We want x coordinate of root 3 over 2, pi over 6, or 11 pi over 6. We want pi over 6 because it's between 0 and pi, top half of the unit circle. So this is pi over 6. So notice that we couldn't just cancel these guys out because this angle is not in the right range. And now here we've got inverse cosine of sine of 7 pi over 3. So again, this one too, we have to work the inside first and then do inverse cosine. So sine of 7 pi over 3 So here we've got 7 pi over 3 is 6 pi over 3, which is 1 revolution, and then another pi over 3. So actually that 7 pi over 3 we can write as pi over 3 if we wanted to. That's an equivalent angle. And then the sine of that is the y-coordinate, root 3 over 2. So this is actually inverse cosine of root 3 over 2 again. And we already did that one in the second part of the example. That's pi over 6. Now one more example here. If we do inverse cosine of cosine, and then our angle, if our angle is between 0 and pi here, then, for example, pi over 4, then in this case, since this angle is between 0 and pi, these guys do cancel out. You just get your pi over 4 back again. So inverse cosine of cosine of x is equal to x if 0 is less than equal x is less than equal pi. And then the other way around, cosine of inverse cosine of x is going to equal x. And this is x between 0 and, or negative 1 and 1. So this way, it's always going to work because this angle is always between 0 and pi. But when you have your inverse cosine on the outside, when that's coming first, you've got to be starting with an angle between 0 and pi.